Okay, so welcome to the second Knox Academy Maths Department video to support parents and carers of S1 pupils. In this video we're looking at solving equations, how we introduce it to our classes and how we want to encourage the pupils to. So first of all, we want our curriculum to build up in steps, and we want pupils to see the connection between the topics so that it's not lots of discrete topics that lack that connection. With that in mind, in the previous video we looked at what a zero pair was and how to work with negative numbers. Now that learning is a pretty essential part of the solving equations work that we're going to do. So I would encourage you, if you haven't already, to maybe have a look at and watch the video on negative numbers. In terms of new learning, well, we're going to build that up first of all by talking about isolating the variable, then how to set up the algebra tiles ready to use. So it's very practical in the early stages of this topic. Then we move that on to how we can solve an equation not only using the algebra tiles, but the formal written method that we want all pupils to work towards. But we want pupils at the same time to understand what it is they're writing, and that's where the algebra tiles come in really useful in the classroom. So let's focus on the first learning outcome in the solving equations topic, which is isolating the variable. So essentially what we've got in every classroom is a pack of algebra tiles for each and every pupil. The pack contains 3 types of tile. First of all, we've got the yellow square, which flips and becomes a red square. Each of these represents a positive one and a negative one. So even the colour coding, the yellow and the red, matches up with the previous learning where we used negative number counters, if you like, or 2 colour counters to represent positive and negative. Then we have these bars. So we have this long green bar, and again if you flip that it becomes a red bar. So each of these bars represents the letter X. So we have positive X for the green bar and a negative X for the red bar. Now in actual fact I can assign anything that I want to those, so actually it could represent a positive A and a negative A, for example. Then we have, and you can see it's just at the back of the bag, we have a blue square tile. Again, if you flip that, we have a red square tile. And this represents a positive x squared tile and a negative x squared tile. So not only is the shape square, we're talking about the term being a squared term. So we make use of these a lot in the early stages of the topic. Pupils have these out on their desks. We refer to them a lot in our PowerPoint slides when we use them, or when we're working at desk level with the visualizer, and we are manipulating and moving these tiles about ourselves as teachers in the classroom. We're isolating the variable. So first of all, the variable is what we refer to as the letter X. So that's the green bar. So what do we need to do? What steps do we need to take to isolate the variable? The only restriction that we put on the pupils is that you have to isolate the variable, but you can't take tiles away, you have to add. So to isolate the variable, we have to add. And this is where our zero pairs work comes in. If we added 2 negatives, what we have there in that little set are 2 zero pairs. We refer to that step as the step where we break the equation. Okay, where the equation no longer is balanced. Okay, it's no longer equal. So what we need to do is we need to repair the equation. Okay, we always have that break and repair step. So to repair the equation, we have to do exactly the same on the other side. So we have to add 2 reds to the other side as well. So I've repaired the equation. It's now equal, it's now balanced again. What we do at this point is we simplify. So we've removed the 0 pairs and we've isolated the variable. We've got the variable x on its own. So moving on to another example, isolate the variable. So we're trying to isolate the letter x there, the green bar, and we have to do that by adding into this model, adding into the set of tiles. So we're thinking really clearly about our 0 pairs knowledge. I have 2 negatives, so we have to add 2 positives, and that has in effect broken the equation. To repair the equation, we absolutely have to do the same on the other side. Now that we've repaired the equation and it's balanced again, we have to simplify. So when we simplify, we're looking for any 0 pairs. As you can see, on the right-hand side of the vertical line, we have no 0 pairs. We have a total of 5 positives. So I've now successfully isolated the variable. Looking at another type, another example here, we want to isolate the variable, and we would have to do that by adding 3 positives into that model, which will 0 pair. To repair the equation and make it equal or balanced, we need to do exactly the same, this time on the left-hand side. So by adding 3 yellows or 3 positives into the model. We can now simplify, looking for 0 pairs. And on the left-hand side, we do have 2 0 pairs there highlighted in the box. So we can simplify that, and we have now isolated the variable. And at this point, we might start talking to the pupils about the value of that variable, the value of that x. So in this case, the variable represents 1 positive, 1 yellow. So we do lots of practice around that. Initially, using the physical algebra tiles, then it might be fading those out somewhat, looking at examples on the board and getting pupils just to write on whiteboards what they would add in to isolate the variable. So starting to make it a little bit more abstract, but only after a lot of practice with the physical manipulatives. This is a really important step, even for the pupils who have previously learned how to solve equations at primary school, for example. What we are trying to emphasise is not only understanding, but the written method and why it's important to write it in a certain way, show working in a certain way. What we've also got, of course, as members of staff in the department is a really strong overview about where we want our young people's algebra skills to progress to. So we've thought that through very, very carefully, and that's why we do want to emphasise certain skills at these early stages in S1, because there's an awful lot of algebra still to come. So moving on, we're looking at setting the algebra tiles up ready to use. We don't necessarily spend a lot of time on this, but it is important nonetheless. So what I've started on the slide here is what we would call an example problem pair. So what we don't want to do, and certainly this was my experience in school in maths, is for pupils to sit through and to copy out 5, 6, 7 worked examples, having no input into that process or very little input into that process. So we use what we call example problem pairs, where we put an example on the board, we talk through that, and different teachers have different ways of doing that. Once we've talked through it, we would encourage the pupils to write it down because it is important to have well-written notes for revision purposes. But then immediately after that, we'll give them the problem part. So we do the example and then they do a very similar problem. Normally, this is done on whiteboards. The pupils then complete the question, show their whiteboard to the teacher as a class, and then the teacher gets a really good feel for what the class has taken from that example that they've went through, if any re-explanation is needed, or if they're ready to move on. So that keeps it quite an engaging and interactive process. So going back to the question, x plus 2 equals 3. We're looking at how we would lay that out using the algebra tiles. So there is the x plus 2, the x and 2 positives. We would represent an equal sign using a vertical line to separate it from the 3 positives that appear on the right-hand side. Part of the reason we use a vertical line is because we would then encourage the pupils to, when they're writing out the equations and when we're using the written method, have all of the equal signs in a vertical line and keep it really well structured. The other reason, when we're using algebra tiles to solve, that we use a vertical line as opposed to an equal sign is because, of course, this idea of breaking and repairing. When you isolate the variable, you have broken the equation. So really you would need to change the symbol from the equal sign to a not equal sign or an unequal sign. And then you would have to repair it, and then you'd have to change the symbol back to an equal sign. So separating it using a vertical line is more efficient as well. But it also emphasises the point that we want equal signs written below each other when we get to that stage. So here comes the problem part for the pupils to try. So x plus 3 equals negative 2. We'd give the pupils maybe 30 seconds to lay out their algebra tiles. So there is the x and the plus 3, and that equals, using the vertical line, negative 2. So 2 negatives, 2 reds. We would do a few of those. So 3 plus x equals negative 2. So there is the 3 and the positive x, because remember, if it was a red x, it would be a negative x, equals vertical line, negative 2. And we would get the pupils to then try this. So there's the 3 positives. This time it is a negative x, so it's a red x equals negative 2. So when we tend to do these problem pairs, whether it's really short and sweet, like this one, or something a bit longer, we tend to try to keep some sort of similarity between our example and the pupil's problem. Just for, again, to emphasise little connections and to spot things that make that process easier for the pupils to understand. So here's another one, x plus 5 equals negative 2. So there's the x and the positive 5. And that equals negative 2. 4 minus x equals 3. So there's the 4 and the negative x. And that equals 3 positives. So we would do a bit of that, like I say. We might even present pictures of algebra tiles on the board and get pupils to do the reverse, which is tell us what the equation is that is represented by the picture of the tiles on the whiteboard at that moment in time. So trying to do things forwards and backwards. And that's a phrase that we often use as a teaching team in the maths department. Can the pupils do it forward? Can they do it backward? Okay, and then that shows a really good level of understanding as well. So let's now look at the actual process of solving an equation using the algebra tiles and a written method. And that, of course, is the stage we want all pupils to get to, using that written method and doing it in a really, really clear way, a way that they understand, and a way that builds strong foundations for future learning, which is what first year maths is absolutely all about. So here we're going to solve the equation x plus 3 equals 2. So x plus 3 equals 2. And what we've got here is side by side, we're going to do the written method along the left-hand side column, and then we're going to model that using the algebra tiles. And eventually we'll fade out those algebra tiles. So the first prompt is we need to construct. We need to use the previous learning on looking at the equation and laying out the algebra tiles. So there's the x plus 3 vertical line in place of the equal sign 2. So what we need to do is we need to break that equation. We need to isolate the variable. And we can only do that by adding into the model. So we need to add in 3 negatives. On the left-hand side, look at how I've written that down. I've put the negative 3 directly underneath the positive 3. And again, that makes it really clear where my zero pair is coming from. And it also matches with what we have in the model, the positioning of the tiles. So of course we need to repair the equation by putting 3 negatives on the right-hand side too. And again, on the left-hand side, I've put my 3 negatives directly underneath the 2. At this stage, we need to simplify. So if we simplify, we get x equals negative 1. Again, what we've got here, if I can just emphasize this for a moment, is the equal signs beneath each other, which represent this vertical line in the model itself. So x equals negative 1. Things that we're looking for, that space there where the zero pair was to isolate the variable is matched in the written method. So here's another example. Solve 1 plus x equals 3. Now, again, a number of pupils will be able to work out, without doing any working whatsoever, that x is 2, because 1 plus 2 equals 3. And that's absolutely fine, and that's great, but we do want to encourage pupils to use familiar questions, use questions that they are familiar with and know the answer to already, to build that confidence, but lay it out in an appropriate way, build those skills. So whilst we don't discourage pupils from doing a question like this mentally, and a number do, we absolutely like to work from familiar problems and familiar questions so that pupils can be confident that their written method is correct before we move on to questions that are less familiar and less easy to work out mentally. So constructing the equation using the algebra tiles. So we've got 1 and positive x, 1 plus x equals 3. We need to break the equation by zero pairing and isolating the variable. So we've added in a negative 1. We need to repair the equation by adding in negative 1 on the right-hand side too. And that is perfectly represented or matched in the written method. At this point, we want to simplify. So we do have zero pairs this time on both sides of the vertical line. And our final answer is x equals 2. So again, a couple things to emphasize. The purple box where the zero pair was is matched in the written method. And also we have that vertical line. So taking a look at another example, we will emphasize another point. Constructing the equation, so we've got 2 and a positive x equals negative 5. We want to isolate the variable by breaking the equation. So this time we have to add in 2 negatives. Again, the positioning in the written method is important. We need to repair the equation by adding 2 reds, 2 negatives onto the right-hand side as well. At this point, we're going to simplify so that we do isolate the variable. So we've got a zero pair on the left-hand side. We don't have a zero pair on the right-hand side. All we've got is a total of 7 negatives. So perhaps at this stage where we would start having conversations with pupils about making sure that they could do these calculations without actually having the tiles in front of them. Again, we've got the zero pair there, 2 and -2, which matches the model. We have the vertical. Okay, so in this example, what we're introducing is this idea of the -x, so the red bar. We still need to break the equation, isolate the variable with a -2, 2 reds. We need to repair the equation by adding the 2 reds onto the right-hand side as well. And after simplifying, we don't have any zero pairs on the right. We just have a total of 7 negatives. We get an answer of -x equals -7. However, when we're solving an equation, we cannot leave the answer as a -x. We have to write the answer as x, a positive x, a green x. So what we do, and this is what we talk about with the pupils, we need to flip the tiles. So if we flipped all the tiles, the red x bar would become green, it would become positive, and the 7 negatives, the 7 reds, would become 7 positives, 7 yellows. And that's how we write our final answer. So x equals 7. So we can't leave an answer with a -x, it has to be a positive x, and we have to flip. And of course we have to flip both sides because that's that idea of breaking and repairing. And doing the same thing on both sides. So, in terms of isolating the variable, zero pairing the 2 negatives and doing exactly the same on the other side and simplifying. What's different about this example though? In this example, we don't just have one x bar, we have 2. So we've started off by isolating the group of variables, the 2 x's, but what we now need to do is we need to share the tiles out. So at this stage we would create equal groups. So I'm just going to share the 2 x's and split them up. I'm going to share the 4 yellows, the 4 positives, equally between the 2 groups. And we can see that each group has exactly the same, x equals 2. And that's what we want. We want to have these equal groups to work out what one of these x bars actually represents numerically. So moving that forward and looking at how we would write that out, solving something like 4x equals 12, we would construct, we would break by sharing into 4 separate groups, effectively dividing. We don't use the division symbol. We use the line and then the 4. We actually think about it a bit like a fraction. So that means separate into 4 equal groups. It's almost similar to 1/4 there, where the 4's on the denominator, the 4's on the bottom. We need to repair by grouping or sharing the 12 into 4. And we write what we've done, we write that step on both sides of the equal sign. We can see that each group contains exactly the same, x equals 3. In the previous video, we looked at something like this as well, where we would share a previous pupil's work. We would talk about the success criteria. So constructing the equation at the moment, this idea of breaking and repairing and simplifying where we can. So moving that on quickly, this is what we would call a two-step equation, essentially, because there's two steps to be done. Constructing the equation, we have our 3x's, our 4 positives, and that equals positive 10. We would start off by breaking the equation. We would start off with, or by, isolating the group of variables. So in this case, to isolate the 3x's, we need to add in 4 negatives. And that's exactly as I've written it here. We have the 10 positives, but we're going to add in 4 negatives onto the right-hand side as well. We can then simplify to isolate that group of variables. So we have 4 zero pairs on the left-hand side, but we also have 4 zero pairs on the right-hand side too. So we get 3x equals 6. Again, just to emphasize, we have that zero pair connection, the positive 4 and the negative 4. But also, something that I've not talked about yet, on the right-hand side, we just have a calculation to follow. So 10 add negative 4 is 6. So 10 minus 4 equals 6. What we need to do then is we need to repeat that process, because I need to work out what 1x bar represents. So we break the equation again. We split up the group of into 3 separate rows, 3 separate groups. We indicate that with a division, but using a horizontal line. That represents 3 equal groups, which is also similar representation to 1/3, where we would share into 3. We have to repair, we have to do the same on the right hand. So I've shared the group of 6 into 3 separate groups. So each group represents exactly the same, and x equals 2. Again, we've got a nice little calculation there. 6 divided by 3 equals 2. So we would go through this a few times with the pupils in the class. We would construct the equation, so 5 and 2 positive x's equals 9. We want to isolate the group of variables. We want to isolate the 2x. So in this case, we would break the equation by adding 5 reds or adding 5 negatives. We need to repair by doing it exactly the same on the right-hand side. We would simplify it at this point. So there's our zero pairs on both sides, and we're left with 2 positive x's equaling 4. Again, we have in the written method the zero pair connection there. It's well laid out and it's nice and clear. We have a calculation on the right hand side. 9 add negative 5 is 4. And we have equal sign below the equal sign in a vertical line. We need to break the equation though, because I cannot solve for a group of 2x's. I need to solve what they are individually. So we need to share. We also need to repair that, of course, by sharing the 4 yellows, the 4 positives, into the 2 groups. And at this point, the pupils can, of course, see that each group is and should be the same. So x equals 2. So after doing a few of those and maybe progressing to purely the written method, we may present the pupils with a little bit of a problem-solving activity to ascertain whether they have understood this idea of breaking and repairing, i.e. what you do on one side of the equal sign, you have to do exactly the same to on the other. So in this problem, we have this equation 4n plus 6 equals 26. And from that, we have 7 other equations. And essentially what we're looking at is we're asking the pupils to think about what they have done to both sides to go from the 4n plus 6 equals 26 to, for example, 4n plus 9. And once they've worked that out, we need to figure out what the new right-hand side is, the repaired side. In this case, for example, if we look at those two, the difference, of course, to go from the plus 6 to the plus 9 is 3 extra yellows. So on the right-hand side, if I was to repair that, I would have to add 3 extra yellows on the right-hand side. So the answer would be 29. So this activity is not about solving the equation. This activity is about working out and probing the pupil's understanding of breaking and repairing. If we took something like this, for example, looking at the similarities and the differences, 4n is exactly the same in both equations, but the plus 6 has changed to a plus 5. So I have added into that equation a negative 1 to change the plus 6 to a plus 5. So doing the same on the right hand side to repair that equation has to be 25. So this is quite a nice activity to question and probe the pupil's understanding. The pupils can then construct one of these spider diagrams themselves and swap it with their table partner. So should you wish to follow up on any of the solving equations work on the Revision Hub, again, as previously talked about in the former video, the Revision Hub is accessible on the school website following this pathway. The curriculum section sits up here. The password is Archimedes1 with a capital A. We have equation work in phase 2 and in phase 3, where we have learning evaluation booklets to describe what has been taught in class. We have practice exercises, answers, and some shorter video tutorials than this. We also have the S1 Smart Targets tab here, which offers bronze, silver, and gold level videos, which have built-in practice exercises for pupils. Those videos won't use the algebra tiles, but of course the end result should be the same. So thank you very much for taking the time to listen in on this solving equations video. I hope you found it useful, and I look forward to next week and talking about the next part.